Have you ever wondered what secrets dinosaurs still hold? Dinosaurs, these magnificent creatures that roamed the Earth millions of years ago, continue to captivate our imagination and curiosity. Their colossal size, their diverse forms, and their sudden disappearance, all these aspects about them spark an endless fascination. Yet despite decades of research, there is still so much we don't know about these prehistoric giants. From the mysteries of their behavior, to their incredible diversity, to the enigma of their extinction, dinosaurs remain one of nature's biggest riddles. And just when we think we've got it all figured out, a new discovery comes along and shakes up everything we thought we knew. So buckle up as we embark on a journey through time to uncover these ancient mysteries. Let's delve into the enigma of dinosaurs, exploring the known, the unknown, and the secrets that these ancient beasts still hold. Did you know that there were more than 1,000 different species of dinosaurs? Yes, that's right. The world of dinosaurs was as diverse as life today, with species ranging from the size of a chicken to giants that stretched nearly 100 feet long. Picture the delicate feathered Archaeopteryx, barely larger than a raven. Now compare it to the Argentinosaurus, a behemoth that shook the earth with each step. This stunning diversity wasn't just about size. Dinosaurs adapted to their environments in fascinating ways. Some developed elaborate horns and frills, others sported wings, and many were covered in a variety of fascinating scales or even feathers. From the swift velociraptor to the armored ankylosaurus, each species had its own unique set of tools for survival. The sheer variety in dinosaur species is just one of the many things that make them so fascinating. The world of paleontology is constantly evolving, with new discoveries that challenge our existing knowledge. Let's delve into the cascade of recent findings that have reshaped our perception of dinosaurs. For instance, the revelation of the Spinosaurus as a semi-aquatic predator, the first of its kind among dinosaurs, has turned our understanding on its head. Or the excitement stirred by the discovery of the tiny bird-like Oculudentavis, opening up a whole new frontier in dinosaur diversity. And let's not forget the groundbreaking find of a dinosaur tail perfectly preserved in amber, complete with feathers and all. This discovery has sparked a revolution in how we visualize these ancient creatures. And then there's the Nanotyrannus, a dinosaur once thought to be a miniature T-Rex, but now believed to be a juvenile T-Rex itself. These discoveries not only enrich our understanding, but also deepen the mystery surrounding these ancient creatures. Around 66 million years ago, the reign of the dinosaurs came to a sudden end. This dramatic halt to the age of the dinosaurs is known as the Cretaceous-Paleogene extinction event, a cataclysm that wiped out about 3/4 of all life on Earth. The most widely accepted theory is that a colossal asteroid or comet struck Earth with the force of 1 billion Hiroshima bombs, causing wildfires, tsunamis, and a nuclear winter that made the planet uninhabitable for most life forms. But the asteroid theory isn't the only one. Some scientists suggest that massive volcanic eruptions in what is now India may have filled the atmosphere with toxic gases and dust, leading to the dinosaurs' demise. Others believe it could have been a combination of both. Whatever the cause, the extinction of the dinosaurs marks a pivotal moment in Earth's history, paving the way for the rise of mammals and eventually, us humans. The extinction of the dinosaurs is one of the greatest mysteries in the history of our planet. Imagine if we could bring a dinosaur back to life. The concept might sound like science fiction, but recent discoveries have brought us a step closer to understanding the building blocks of these ancient creatures. In certain extraordinary circumstances, soft tissues from dinosaurs have been preserved, offering a tantalizing glimpse into their biological makeup. This soft tissue preservation has raised the possibility of finding dinosaur DNA, the blueprint of life itself. However, extracting and reconstructing dinosaur DNA is a Herculean task, riddled with technical and ethical challenges. DNA degrades over time, and the oldest DNA ever recovered is less than 1 million years old, a blink of an eye in the dinosaur timescale. Nevertheless, the quest for dinosaur DNA continues, driven by our insatiable curiosity about these magnificent creatures. The possibility of dinosaur DNA opens up a whole new world of exciting, albeit challenging possibilities. What were dinosaurs really like? This is a question that has intrigued scientists and dinosaur enthusiasts alike for centuries. We've pieced together a picture of dinosaur behavior from the fossil record, but there's still so much we don't know. For instance, we know that some dinosaurs lived in herds thanks to fossilized footprints that show large groups moving together. We've also found evidence of dinosaur nests, suggesting that some species cared for their young, much like modern birds. And then there's the fascinating world of dinosaur mating rituals. Some species may have used their elaborate horns and frills to attract a mate, while others might have performed complex dances. There's also evidence to suggest that some dinosaurs were active hunters, using their sharp teeth and claws to take down prey. But these are just pieces of a much larger puzzle. We're still learning, still discovering, and still trying to unravel the mysteries of dinosaur behavior. Understanding dinosaur behavior helps us see these creatures as more than just fossils. Did you know some dinosaurs were feathered? Yes, it's true. The idea of a Tyrannosaurus rex with a fluffy coat might seem odd, but there's compelling evidence to suggest that feathers were far more common among dinosaurs than previously thought. Fossils from China in particular have revealed a startling number of dinosaur species with evidence of feather-like structures. These feathers likely served various purposes, from insulation to display to, in some cases, flight. The evolution of feathers in dinosaurs is a fascinating topic of ongoing research. For instance, scientists are still unraveling the complex genetic and developmental processes that might have given rise to feathers in the first place. Moreover, the precise role of feathers in dinosaur life, whether for warmth, mating displays, or even early forms of flight, is still a hot topic of debate. The idea of feathered dinosaurs challenges our traditional image of these creatures, but it also paints a more vivid, colorful, and dynamic picture of the ancient world they inhabited. How did dinosaurs communicate with each other? That's a question that has fascinated scientists and dinosaur enthusiasts alike. It's widely believed that dinosaurs, like their modern-day descendants, the birds, had a variety of ways to communicate. Some dinosaurs might have used visual signals like changing skin color or performing specific movements. Others could have relied on auditory signals, emitting sounds similar to the roars, growls, or calls we associate with modern animals. There's also the possibility that some dinosaurs used tactile communication, touching each other with their bodies or tails. But studying dinosaur communication is a complex task. After all, we can't directly observe their behavior or hear their calls. Much of our understanding comes from comparing dinosaurs to their living relatives and from studying their fossilized remains. But there's so much we still don't know. Communication is a key aspect of any animal's life, and dinosaurs were no exception. The mystery of how these ancient creatures communicated continues to intrigue and inspire us. How smart were dinosaurs really? You might picture dinosaurs as lumbering beasts, but some species defy this stereotype. For example, consider the troodon, an agile predator with a brain-to-body size ratio similar to that of modern birds. This suggests a level of intelligence comparable to our feathered friends. To gauge dinosaur intelligence, paleontologists rely on a measure called the encephalization quotient, or EQ. This compares the size of an animal's brain to what we'd expect for its body size. The higher the EQ, the smarter the creature is thought to be. By this measure, some dinosaurs score quite high, indicating a level of intelligence we might associate with certain mammals. Still, this is a hotly contested field. Some argue that a big brain doesn't necessarily mean high intelligence. Also, without a time machine, it's impossible to truly know how these prehistoric creatures thought or behaved. The question of dinosaur intelligence is a fascinating one that continues to intrigue scientists. How did dinosaurs care for their young? It's a question that has tantalized paleontologists and dinosaur enthusiasts alike. From what we know, dinosaur parenting behavior was as diverse as the species themselves. Some dinosaur species, like the Maiasaura, were quite the attentive parents. Their nesting sites, often found in close-knit colonies, suggest a communal approach to raising their young. Interestingly, fossil evidence shows that these parents would bring food to their hatchlings until they were old enough to venture out on their own. This nurturing behavior provides a fascinating window into the social dynamics of these ancient creatures. On the other hand, other species like the massive titanosaurs seem to have adopted a more laissez-faire approach, laying their eggs and leaving them to the whims of nature. So whether it was the careful nurturing of the Maiasaura or the hands-off approach of the titanosaurs, dinosaur parenting behavior gives us a glimpse into the social lives of these ancient creatures. What made some dinosaurs so gigantic, and how did others take to the skies? It's a mystery that has intrigued paleontologists for generations. When we think of dinosaurs, we often imagine colossal, earth-shaking beasts, but not all dinosaurs were gargantuan. Some were as small as chickens, yet they shared the planet with giants like the Argentinosaurus, which could grow up to 90 feet long. So why such a size disparity? One theory suggests that gigantism was an evolutionary response to environmental changes, providing dinosaurs with survival advantages like increased strength and greater reach for food. But with size comes constraints. The larger the creature, the harder it is to move quickly, or in the case of some dinosaurs, to fly. Yet we know some dinosaurs did take to the skies. How? It's likely that flight evolved gradually from gliding or leaping abilities in smaller, feathered dinosaurs. But like many aspects of dinosaur life, the exact details remain a mystery. The size and flight capabilities of dinosaurs are among their most fascinating aspects. What colors were dinosaurs? This question has puzzled scientists for decades, and only recently have we begun to unlock the secrets of dinosaur pigmentation. The key to this puzzle lies within the microscopic structures within fossilized dinosaur skin and feathers, known as melanosomes. These tiny structures contain pigments that give color to animal tissues. Scientists compare the shapes and arrangements of these fossil melanosomes with those of modern birds and reptiles to infer possible colors. This method has revealed that some dinosaurs, like the Microraptor, were iridescent black, while others, like the Anchiornis, sported a flashy array of red and white feathers. However, determining colors from fossils is not foolproof. Preservation conditions and the passage of millions of years can alter melanosome shapes, potentially skewing our color interpretations. Yet, these exciting findings open a vivid window into the prehistoric world, painting a more colorful image of our favorite giants. Knowing the colors of dinosaurs adds another dimension to our understanding of these creatures. Have you ever looked at a bird and thought, "That's a dinosaur"? It might sound far-fetched, but it's a scientific fact. Birds are the last surviving lineage of theropod dinosaurs, a group that also includes the mighty T-Rex. Intriguing, isn't it? The clues to this connection are everywhere, from the hollow bones that make flight possible, to the three-toed footprints, similar to those left by dinosaurs millions of years ago. Even the way birds nest and protect their eggs echoes the parenting behaviors of some dinosaurs. But it's not just about the similarities. The bird-dinosaur connection also helps us understand how evolution works, how traits like feathers, initially evolved for insulation or display, can be repurposed for flight. So, next time you see a bird flitting from tree to tree, remember, you're not just looking at a bird, you're looking at a living, breathing piece of the dinosaur legacy. The connection between birds and dinosaurs is a testament to the enduring legacy of dinosaurs. Opening. How do scientists study dinosaurs? Decoding the mysteries of the past requires a blend of traditional methods and cutting-edge technologies. Paleontologists, the detectives of prehistory, employ a range of tools to bring the ancient world to life. From the humble pickaxe and brush for meticulous excavation, to sophisticated software for analyzing fossil data, this field is as diverse as it is intriguing. One of the most significant advancements in recent years is the use of computed tomography, or CT scanning. By creating detailed three-dimensional images of fossils, scientists can study the internal structures of dinosaur bones without damaging precious samples. Another exciting development is the use of three-dimensional modeling. These digital reconstructions allow paleontologists to test theories about how dinosaurs moved, ate, and behaved, giving us a dynamic view of these incredible creatures. Ending. Modern technology is helping us unravel the mysteries of dinosaurs like never before. What does the future hold for dinosaur research? Well, it's a thrilling frontier teeming with potential discoveries. The advancements in technology are propelling us into an era of unprecedented dinosaur exploration. Tools like CT scanning and 3D modeling are allowing us to recreate these creatures in ways we couldn't have imagined a few decades ago. The hunt for dinosaur DNA continues, and should we ever find it, this could revolutionize everything we know about these fascinating creatures. Future research may also shed light on unsolved mysteries like the enigma of dinosaur coloration or the tantalizing link between dinosaurs and birds. There's so much about dinosaurs that we still don't know. But with every new discovery, we inch closer to understanding the lives of these magnificent creatures that once ruled our planet. As we delve deeper into the world of paleontology, let's remember that every fossil holds a story, waiting to be told. The future of dinosaur research promises to be as exciting as its past. The world of dinosaurs is filled with enduring mysteries. As we've journeyed through the diversity of species, recent discoveries, theories of extinction, and the potential of dinosaur DNA, it's clear that these ancient creatures continue to captivate us. We've delved into dinosaur behavior, from potential communication methods to their cognitive abilities. We've examined the evidence for feathered dinosaurs and explored the puzzling aspects of dinosaur gigantism and flight. We've tried to unlock the secrets of dinosaur coloration and investigated the intriguing connection between birds and dinosaurs. Through modern paleontological techniques, we've seen how researchers are unearthing new insights into this bygone era. And yet, despite these advances, many mysteries remain. How did dinosaurs truly behave? What were their colors? How intelligent were they? And the most tantalizing question of all, could we one day bring them back? As we continue to explore these mysteries, who knows what exciting discoveries await us in the future?